Hello, my name is Brandon Beyer. I manage a global team of customer-facing technical professionals within the household and institutional cleaning vertical at Univar Solutions. Welcome to Green Does Clean. Today we're going to talk about a few topics. What is green? Why do we care? And the big question, do green solutions actually clean? Cleaning touches almost every part of your day. Whether you're doing laundry or washing dishes, cleaning is woven into our daily routines. Laundry and dishes are familiar to everyone, but those of us in the cleaning industry spend a lot of time also thinking about and defining hard surfaces, which can be wide and varied. They can be horizontal or vertical, made of wood, tile, steel, etc. They could be located in bathrooms, kitchens, driveways, the siding of your home, or the inside of a car. Regardless of where or what you are cleaning, green and sustainable solutions are impacting you even if you are unaware. These products go down the drain and can impact wastewater and ultimately our lakes, rivers, and streams. Cold water washing requires less energy, which has an impact on the energy grid. 1X products have been concentrated to 2X, 4X, 10X, or even 100%, and are now commonly delivered in reusable and recyclable packaging. Green cleaning is here, and it is part of your everyday life. But why do we care? The information age has created an increasingly educated and demanding customer. Whether these are formulators at the bench or end-use consumers, the future of cleaning needs to respond to this high level of base knowledge. What do customers want from their cleaning solutions? They want cleaner clean or maximum cleaning efficacy from their products. The products need to be safe, cost-effective, and easy to use. They need to be green and delivered in eco-friendly packaging. Labeling transparency is also important, and finally, customers love multifunctionality in their products. Much of this list either directly or indirectly impacts what we call green cleaning. If we are to move with the industry trend and consumer requirements, we need to take this topic seriously. When it comes to green cleaning, there are a lot of questions and challenges for a chemist or formulator. The household and industrial cleaning team at Univar Solutions is confronted multiple times a week with some iteration of the following request. I want to go green, or I need my products to be more sustainable. It's an important but often vague request. So we're tasked with turning green and sustainable into an actual actionable product. That starts with the definition. So what is green? Green means different things to different people. What does green mean to you? Do you literally just see the color of green with some molecules floating around? Does it evoke imagery of plants, flowers, and essential oils? Perhaps it is a vision of your home as a sanctuary with very strong spa vibes. To me, green cleaners are the farm-to-table approach to an industry I have devoted almost 20 years. That makes traditional cleaners a bit more akin to cheap fast food. They are effective, but they come with some baggage. More on that in a minute. Green cleaning has also become a popular topic among influencers, or clean fleurs as I like to call them. You do not need to search long to find a cleaning hack based on using baking soda, vinegar, and lemons. These can actually work in some applications, and it opens our dialogue up to the actual contents of a green, sustainable product. When it comes to chemistry, green has a few core characteristics. No phosphates, no chlorine, fragrance-free, no pigments or dyes, and bio-based. So we have some basics about what might be in a green product and how green is perceived as a concept, but we have not yet defined it. I believe it is important to set a baseline definition. Why? The first reason is to prevent greenwashing. Greenwashing is a real threat to consumers. Greenwashing is a process of conveying a false impression or misleading information about the environmental impact of a product. It can be used to overemphasize the sustainable aspects of a product while ignoring deleterious environmental baggage. It is often performed through environmental imagery, vague and misleading labels, and ultimately attempts to capitalize on the growing demand for nature-friendly solutions. This is why we spend some time asking what images and concepts do you associate with green. It allows you to identify your own bias and make informed decisions when selecting products or ingredients. Is the solution you're choosing really green, or is it cleverly marketed to play on your built-in perceptions? A second reason we need a definition for green is to prevent green confusion. Green confusion is a result of the lack of a single set standard for green, sustainable products. There are myriad green labels to delight and confuse: Safer Choice, RSPO, EcoCert, Nordic Swan, etc. And there are just as many green terms, inherently or readily biodegradable, bio-based, reusable feedstocks. With no set international standard to define green, what do? At Univar Solutions, our answer is to set down a series of parameters for how we can talk about green and sustainable products with customers and suppliers alike. Univar Solutions has defined the following sustainable product characteristics: natural or bio-based, carbon footprinting, safer substitutes, circular materials, social impact accreditation, environmental accreditation. Each product characteristic is supported by evidence from suppliers, often third-party, at the product level. To be transparent, each sustainable product at Univar Solutions will be characterized in this framework. This is the first step, as product sustainability emerges in chemicals and ingredients. So we have a definition, but do these products and chemistries actually work? Does green clean? Let's talk a bit about cleaning. Allow me to introduce the Sinner's Circle. It was developed in 1959 by Herbert Sinner and is a simple and elegant way to describe the levers in cleaning. The circle illustrates the four main physical factors of cleaning. Chemistry is usually the cleaning solution. Temperature affects the efficacy of the cleaning solution. Mechanical action is the physical power exerted to scrub away a soil. And the exposure of time impacts all three factors. At the center of Sinner's Circle is our universal solvent, water. This visual is a useful way to depict the nuances of cleaning. Let's look at examples from laundry. Sinner's Circle can capture the differences between advanced laundry application, which is depicted by the image on the left, or traditional basin washing, which is illustrated on the right. The traditional approach is inherently green. Time is however long you need to get a garment clean, mechanical action is sweat equity, temperature is determined by nature, and the chemistry is a minor component. The advanced laundry approach is what we are really talking about today. There is substantial reliance on chemistry to drive cleaning, and per our topic today, that chemistry needs to have a favorable ecological profile, enable less energy use, and the faster it works, the less energy is needed to drive a laundry wash wheel. It is not all chemistry though. Green cleaning can also be driven almost exclusively through water levers. Heating water requires a lot of energy, whether we're talking about a laundry application, dish, or car wash. Reducing the need for hot water is a win for a more sustainable future. This is not always easy, as reducing temperatures and maintaining cleaning performances requires innovation and testing, but simply turning down the temperature of the water is a potential green solution. A second lever is the amount of water required to rinse a product or soil from a surface. There are some obvious limitations to this lever based on the application. We are not going to find a way to reduce the water required to rinse an entire car down to a single drop. But through technologies like rinse aids, the amount of water required and the speed at which it sheds from a surface can be reduced. A final example is water content within the products themselves. This is the essence of compaction. Supply chain leaves its own environmental impact, and shipping drums and totes of products that are predominantly water never feels great. In the ideal scenario, we're shipping highly concentrated products with little to no water. Without making a single new chemistry, there's room to grow into more environmentally friendly product usage simply by lowering water temperatures and reducing water content. However, if that is where we stopped, I can confidently say that green would not clean. Reducing temperatures needs some help to maintain performance. When we take a deeper look at green cleaning chemistry, it is important to remember it does not have to be an all or nothing approach. If you're starting on the more traditional side of the spectrum with nanophenols and phosphates, you have a great cleaner, but one with some environmental baggage. Do you need to go all the way to enzymes and microbes in a single formulation leap? No. Green cleaning can be, and often is, a journey. Moving from synthetic to natural, non-biodegradable to readily biodegradable, from synthetic feedstocks to natural, renewable feedstocks can all be steps towards green cleaning. Green solutions suffer from challenges in perception, which is the whole point of my talk today. Do these products clean? Are they too expensive? Are they really green, or is it all marketing? How can you tell the difference from a more sustainable cleaner versus a purely synthetic option? Two visually identical products can have wildly different ecological profiles and performance. Laundry offers a great opportunity to illustrate just how far the innovations in green cleaning have come. How do we prove that one solution performs better than another? How do people like my colleagues and myself develop and test laundry products? The answer? We do laundry. We do lots of laundry. The difference between what you all do every day and what we do in lab is the addition of soil swatches. These are preset stains that allow us to measure the efficacy of a cleaning solution. When we are comparing a traditional laundry cleaner to a green cleaner, this is the crucible through which these products must pass. If our green solution does not remove chocolate, grass stains, body soils, makeup, or any soil you can imagine, it is not a viable option. With the addition of enzymes to the classical laundry package of surfactants, dispersant polymers, and chelants, these green laundry solutions perform as well, if not better, than the laundry products from decades previous. So does green clean? When it comes to laundry, absolutely. However, I've only talked about laundry, and to be completely transparent, that is because it is one of our best examples of successful green cleaning. Green does clean, but there are gaps in some applications. Gaps that are closing as new chemistries arrive every day. Old chemistries are being remade from alternative feedstocks, so you have traditional chemistry, or the same molecule which may have come from petrochemicals in the past, being generated via bio-based pathways today. Enzymes continue to redefine what can be done at reduced temperatures. Microbes and the surge in microbial cleaners give access to continuous cleaning. These products can continue to work and clean hours and days after they are applied. Does green clean? Yes. Does it depend on the application and how well it cleans? Absolutely. This makes our job both important and fun. We as an industry need to close the gap where performance is lacking and continue to drive improvements where we are already enjoying green success. Green cleans, but not everything. At Univar Solutions, we are here to help identify where your green cleaning gaps exist, turn them into actionable projects, and continue all of our journeys along the green spectrum. So the next time I give a talk like this, I can definitively say, green does clean with no gaps and no caveats. Thank you so much for your time. If you have any questions, please do not hesitate to reach out to the Univar Solutions Home Care and Industrial Cleaning team.
Thank you for that presentation, Brandon. That was wonderful. We have some common questions that I think will be very useful for the audience. So I'm just going to dive right in.
Okay, thank you.
So question one is, what is the most important green attribute of a finished product or a raw material?
You know, Megan, this really needs to be defined by the consumer or formulator. So my answer is going to be a bit of a non-answer, but I would say you need to define what is most important to you up front, whether that's, say, biodegradation, EPA labeling, etc. It's important to remember, in addition to that, though being green is really important, sustainable, that's where we want to be, you can't forget performance and cost. So a lot of times when people come to myself and my team looking for the same question, we spend a fair amount of time upfront defining green, sustainable, before we even start with formulation. So you know where your target is, you know, and per the presentation, it's a journey. It doesn't have to be all at once. But the biggest thing is when you come in, even if you don't know, Univar Solutions, the team can help you define green. And if you do know, help communicate that to people you're working with, and we can get you to a solution.
Wonderful. Okay. The next question, why were NPEs and phosphates removed from so many products? They really seem like great cleaners.
You know, they are. Make no mistake, NPEs and phosphates are spectacular surfactants and water conditioners, respectively. The initial pushback on a lot of green solutions, and I lived through this personally, was that there was such a big performance and cost gap because the NP and phos blends work so well. But a little more background, NPs are considered to be endocrine receptors. It's a really weak effect, but the concentrations are high enough to make this a concern, especially in aquatic environments. They're also moderately bioaccumulative, so they're not readily biodegradable. Phosphates are a concern because they can lead to eutrophication. That's a process where a body of water becomes overly rich in nutrients. Sounds good at first, but it can lead to harmful, like algae blooms, reduce oxygen in the water, and ultimately lead to what we call dead zones. So great cleaners, they just come with some environmental baggage.
Got it. Got it. All right. Next question. Are preservatives considered green and sustainable? Isn't their primary function to inhibit growth or kill? I mean, if I have to use a preservative, can my product be considered green?
Yes. So a couple thoughts. One, there are preservation technologies that are considered green, such as, say, benzoates. They're inherently natural. Systems could also be self-preserved at very high or very low pH, where you don't even need to add a chemical preservative. But as a thought concept, right, green has a core principle of waste reduction. And if the product goes bad due to bacterial growth, you run the risk of being too green for your own good. So sometimes trade-offs need to be made. What would be more wasteful and less sustainable green than making a 10,000 kilogram batch and having to throw it away in 2 weeks because you've got fungus, mold, bacteria, whatever growing in it? And you can read the news. There are cautionary tales where this has happened. It's a very big concern. So sometimes trade-offs need to be made, or sometimes there are preservatives that work within a pH range that can allow your solution to be entirely green per some, general definition.
Next question. Where are most new innovations occurring in support of greener products and raw materials, new molecules, things of that nature?
There's a lot of spots. This is a personal opinion, but I think there are new molecules. But I think we're seeing a lot of the movement right now, at least in terms of basic chemistries, old chemistry being made in new ways. So say a less sustainable or, a product that was made from completely synthetic feedstocks, made from maybe plant-based feedstocks or waste streams, process improvements. So maybe the chemistry is exactly the same, but the overall carbon footprinting and the way the material is made is more sustainable for the greater environment. And then there's biotech. There's things we've made through reactors for years that are now being generated through microbial action. So people are literally using bugs to do synthesis to grow, new molecules or old molecules. I would say, in addition to that, there's improved data metrics and performance monitoring, just water and energy usage. So you can actually show that you have a more sustainable process or a product that works at lower temperatures and whatnot, because we can actually see the data. You use less water over a week, a month, a year. Concentrates, taking things from 1x to 2x to 100% concentrated, perhaps solids, powders. That's another move in really the green sustainable front. And the last thing that comes to mind is microbial cleaners. So the idea of using, probiotics, good bacteria to help support, the action of long-term continuous cleaning. So you put it down, you get it clean, the microbes hang around and keep generating enzymes. And everything we think of as a soil, is a food to them. So get it clean, keep it clean, and the microbes exist to continuously clean. So kind of 4 areas: old chemistry made new ways, improved data metrics, concentrates, and microbial cleaners. That's first things that come to mind in terms of where most of the innovations are happening today.
Wonderful. This is a great session. Thank you so much, Brandon. And thank you everyone for joining us on this session, Green Does Clean. If you have any questions, reach out to our team. We're happy to follow up and help on all things cleaning. Thanks again, Brandon.
Thanks a lot, Megan.